Hey everyone, welcome back. Mr. Skelton here, back at it. Lesson 2, Unit 8. And today we're going to be talking about the second type of sequence in this unit, which is the geometric sequence. If you remember from Lesson 1, we talked about arithmetic, right? And an arithmetic sequence is when we're adding something to the same term, 2, 4, 6, 8, 10, dot, dot, dot. We're adding 2 to every single term. That's called the common difference. D would be 2. And that's an arithmetic sequence. All right? And we learned about an explicit and a recursive formula to find the previous term and then any term we want in an arithmetic sequence. Today we're going to be doing kind of the same thing. We're just going to be talking about what a geometric sequence is, and we're going to be doing the same thing we did in 1. I need a recursive, which is based off the previous term, and then explicit, which allows you to find any term. I'll put previous here to find terms within a geometric sequence, and then we're also going to find the geometric mean, which is different from arithmetic mean. Okay, so let's just jump right into it. So here I have a definition of a geometric sequence at the top. A geometric sequence, has a common ratio. We call that the R value. So R is the common ratio, which means it's a sequence in which to get the next term, you must multiply the same number over and over, okay? Just like up here with the geometric or the arithmetic, plus 2, plus 2, plus 2, it's that same number over and over. You can't have plus 2, plus 4, plus 6. You can't have different numbers in a sequence. You got to add the same thing over and over again for the common difference. You have to multiply the same thing over and over. That's why it's called the common ratio. It's the same thing. Just like we did in arithmetic sequences, in geometric we have the recursive formula and we have the explicit formula, and they're very, very similar. So if you just take a look at it here, to find the next term, we're taking the previous term and we're just timesing it by R, the common ratio. Again, we're multiplying. With the explicit formula, when you multiply a number over and over again, what are you doing? Well, in my mind, I immediately think of like 2 to the third power. I'm taking 2 and I'm multiplying it over and over again. So this should make sense because it's going to become basically an exponential function because we're multiplying the same number over and over again. That's why this is an exponent. That's why your n minus 1 is an exponent. Okay, so let's take a look at the first one. We have 5, 10, 20, 40, and 80. Again, I always label my terms. Okay, so I want for the directions on this one, I want the next term. So basically, I want a sub 6. So that would be our recursive formula. So that would be a sub 6 equals a sub 6 minus 1. I'll write it out for you. Times. Now, what are we doing to each term? Hopefully you can see we are timesing by 2, right? We're timesing by 2, we're timesing by 2. It's all the same number, so my ratio, my common ratio would be a 2. And so this would be a 2 because I'm just following my formula. So a sub 6 would equal a sub 5, the previous term. 5 comes before 6. And we're timesing that by 2, so a sub 6 equals 80 times 2. A sub 6 would be 160. Okay? That is how you use the recursive formula to find the next term. Again, we don't use the recursive formula a whole lot because in order to use it, you need to have the previous term. So let's take a look at the second example here. It says find the 34th term. All right, so we have a sub 34 equals the first term in our sequence is 5. So this is how I think about it. If I want to find the 34th term, I got to start somewhere. So I'm starting at 5. And then I'm going to times that 5 by my common ratio of 2, n minus 1 times. Now I'm going to repeat what I said already in the arithmetic sequence video. Why is this n minus 1? Well, take a look. To get to my 5th term of 80, focus on the term number 5. How many times did I multiply 2 by the 5 to get to 80? To get the 5th term, I multiplied 5 by 2, 1, 2, 3, 4 times. 5 minus 1, 4. If I find the fourth term, look at the fourth term, which is 40. How many times did I multiply 2 by the 5 to get 40? 1, 2, 3. 4 minus 1 is 3. That's why it's n minus 1. So the 34th term, I have to start somewhere. I have to start at 5. That's the first term. And I'm timesing that by 2 33 times. So you just take your calculator out. 2 to the 33rd power is a massive number. And then I'm going to times that by 5. And I get something crazy. I probably shouldn't have picked the 34th term, but 8 to the 34th is going to be, I'll just keep it in scientific notation, 4.29 times 10 to the 10th is what my calculator is saying. All right? I probably should have picked a different number. That's way too big. I should have picked something like, let's do like 15, 8 to the 15th. 8 to the 15th would be it'd be 5, that's my first term, times 2 to the 14th. Let's see if that gets a little smaller. 2 raised to the 14th. There we go. Let's times that by 5. There we go. So the 15th term is going to be 81,920. So that's how you would do something like that. Okay, let's flip it over. I just have a bunch of different examples here. Why don't you go ahead and try, just try the top one, and then we'll come to the second one together. All right, 1, 2, 3, 4, fifth term. What am I doing to each term? I'm timesing by 2. Tried to give you a couple basic ones here. So find the sixth term. That means I'm going to use the recursive formula. So a sub 6 would equal the fifth term times, I'm timesing everything by 2. And so a sub 6 would equal a sub 5, which is 48. The fifth term is 48. Times that by 2. And that should give you 96. Okay? Find the 22nd term. So in my head, here's what I'm thinking. Okay, I want to find the 22nd term. Where do I start? I got to start somewhere. I start at 3. Now, how many times am I going to multiply 2 by on this 3? Well, if it's the 22nd term, that means I need to do it 21 times. So 2 raised to the 21st, and then times that by 3. And so my 22nd term is going to be 6, 2, 9, 1, 4, 5, 6, 1, 2, 3, 1, 2, 3. So 6,291,456. Cool. Next, salary, kind of a salary question here. So I don't have much space, I'll put them underneath 1, 2, 3. So that's my first term, second term, third term. What am I doing to get the next number? Now, this may be challenging to figure out what are you, like this was times 2 times 2. What am I doing to 26,000 to get to the next term? So you may need to play around with your calculator a little bit and try some different things. It kind of just depends on, you know, what you're doing, but I'll give you a hint. If you don't see one that comes off real easy like this, just go backwards. Go from the second term to the first term and divide. Divide them out, right? Like 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. A lot of people can't see, what did I multiply 26,000 by to get 27,040? But watch what happens when you take 27,040, divide it by the first term, 26,000, you get 1.04. Just double check it. 28, take the third term, divide it by the second. 28,121.6 divided by 27,040, 1.04. So basically, I'm timesing everything by 1.04. Timesing by 1.04. That's my common ratio. My R value is 1.04. That's important. Okay, so if you can't see it right away, use that little trick of the trade there. You'll be good to go. Salary after 18 years. So I didn't ask for the fourth term. I'm asking for the 18th term. I got to start somewhere. I'm starting at $26,000. So I want to figure out how much I've made, or how much I'll have after on my 18th year of working. I'm timesing 1.04 how many times? 17, right? To get 18 years, I need to multiply 1.04 17 times. So 1.04 raised to the 17th power. And then I'm going to times that by 26,000. And that gives me a to the 18th. The 18th term is going to be 50645.41. So $50,645.41. That's what you'll make in your 18th year on the job. That's not the total over all 18 years. That's just your 18th year. Okay, second question, how many years will it take to make $91,000 and some change? So 91209.52 equals, where did we start? We started at our 26,000. We times 1.04. How many times? N minus 1, right? So how do we solve this now for n? Good question. We have to, this is time, so I'm going to divide by 26,000. So I'm going to take my 91209.52. I'm going to divide by 26,000. So I basically get 3.508, okay, equals 1.04 to the n minus 1. Now how do we solve that for n? We're solving for an exponent. What do? We got to use logs. Log base 1.04. Right now you're going, no, logs are coming back. Okay? Now I left this in my calculator. I didn't round it because I want to go change a base formula here, right? So I'm going to go log of second answer divided by the log of 1.04. Okay? I get basically 31.99, okay? So I'm going to go 32 here equals n minus 1, and then add 1, so n equals basically 33 years is what it's going to take me to get $91,000 for my paycheck, if that rate was steady all the way through. All right? So good review of logarithms there. Nice question. Let's go on to the next one. Try this one on your own, and then we'll talk about geometric mean, which is right underneath it. Okay, so again, it may be one of those situations where you may be asking yourself, what am I doing to get from 80 to 60, 60 to 45, 45 to 33.7? Ooh, I'm not sure. So let's just go backwards and go 60 divided by 80. I get 0.75. I'm going to go 45 divided by 60, 0.75. 33.75 divided by 45, 0.75. So what am I doing to get to the next term? I'm timesing by 0.75. Right? If you're not sure, do the division trick. Okay? 14th term, so a to the 14th equals, okay, in my head I'm thinking, where do I have to start? I'm starting at 80. I have to multiply everything by 0.75 how many times? 13 to get to my 14th term. So 0.75 raised to the 13th power, times that by 80, and I get the 14th term of 1.90058, and I'll probably be more specific on how I want you to round, etc., but that's what we would have for our 14th term. What term number is 0.3382? Well, so that's where we start. 3382 equals, I started at 80. I times that by 0.75 to the n minus 1. That's our explicit formula. So I would divide by 80. So 0.3328 divided by 80 equals 0.00416 equals 0.75 to the n minus 1. I didn't leave you a lot of space, did I? I apologize. We're going to log 0.75 both sides. So this becomes 1. So now I'm going to just go log of second answer divided by log of 0.75. Hit equals, and I get 19.06, and then I'm going to get n minus 1 equals that. So I basically add 1 to this. So 20.25, so that basically the n equals the 20th term. Okay? And that would be our answer for number 2. Okay? Geometric mean. Again, it's just another, what mean is finding the average. So instead of arithmetic, where you took two numbers like 2 and 8, and we added 2 and 8, right? We took 2 plus 8 divided by 2, we'd get 5. Now we're going to multiply these two, and we're going to take the square root of the two numbers. All right? So that's geometric mean. So again, it's just another way to find average. So we're going to take these numbers of 8 times 32, and we get 8 times 32, which is 256, okay? And then I take the square root of that number to find the geometric mean. So basically, the square root of 256, you may know it, it's just 16. Again, it's just another way of finding average. If you remember from your algebra or your geometry days, geometric mean, we set them up like this. We'd go n over 8 equals 32 over n, and we would just cross multiply. That was geometric mean. So you'd get n squared equals 256. We used to write out the equation in geometry. All right. So this second example here, if you wanted to write it out like in your geo days, so it's 28 times 5103, and then take the square root of that. You should get 378. Okay. I did put some questions there at the bottom. What's the difference between arithmetic and a geometric sequence? Arithmetic has a common difference where you're adding and subtracting the same number. Geometric sequence has the common ratio where we're multiplying the same number. Okay, what's the difference between arithmetic and geometric mean? Arithmetic mean, we're adding and dividing by 2. So we're adding the numbers and dividing by 2. Here on geometric, we're multiplying the two numbers and we're taking the square root of those. So a couple quick reminders on the difference between the two. Okay? So we've covered the two basic types of sequences, and we're not going to really do anything more with sequences other than just arithmetic and geometric. We're going to focus on those in these first two lessons, and then they're going to carry over throughout this unit. All right? Look forward to answering your questions in class. Take care.